Hello everyone. So the bottom line of PBN is the type of benefits uh, that can bring to a modernized ATM system. So if you look at this table we have here, just with the basic RNAP 5, remember, the separation is, depending on whether we are in the same direction, opposite direction, or all the types, is around, so to speak, 15 nautical miles, or even if you want 14 nautical miles. So in order to design our structure of ATS routes, we should ensure 15 nautical miles between one and the other due to the lateral errors we can ensure with this system. If we add on top of that turnings, the spacing is much larger. I don't know how much, but much larger. Now, when we move to precision RNAP, this goes down to 8 nautical miles, and is larger because we don't have fixed radius transitions when turning, so that we cannot properly define the path, the curve the aircraft is following. So we need to allocate more buffer, more safety buffer, and this is somehow compromising the design of our network of routes. When we move down to RMP or advanced RMP and route and terminal, the separation is 7 nautical miles, right? And even in turnings, and this is going to be very important when designing departure and approach procedures, the separation stays the same to 7 nautical miles. In other words, from what we have today in the Spanish airspace, in the route, basic RNAV, to what we could have with RMP, RMP4, RMP2 for en route, we could double the capacity by reducing the distance between airways to 1/2. We can populate with more and more airways, and thus eventually handle more traffic. I don't know if doubling the traffic, because there might be other collateral effects, but this is kind of a good thing we can do, and we eventually would need to increase the capacity of the system because it has been reaching its limits in 2018, 2019. We've accumulated a lot of delays. Now, other things. So if we look at the approach, we can design better approach procedures, as it is the case here. We can establish, here we have this, you see this radius to fix approach, and it's now very typical that you find something like this, gridded approaches, in which the controllers and the pilot don't need to do holdings, they just allocate the aircraft to one of these because they know the aircraft has the capabilities to follow exactly the path, and also you can instruct time windows to the different points, to these checking points, take decisions, and all in all, a smooth traffic, increase the capacity of the throughput of the airroom, reduce delays, reduce unnecessary holdings, etc. That's one example. You can see it here. I was saying they follow the track. Just see it. Conventional operations. The radar track is a mess. A lot of directs, right? Pilots, controllers asking for directs. A lot of errors, overshoots in the trajectory. So this, of course, is increasing the complexity, jeopardizing at some point safety, etc. And you see that with PBN, they exactly follow the track with minor errors. Of course, if they have, if pilots and aircraft, they have more efficient routes with curves that go through where they think is the most efficient way to proceed, they're not going to ask for directs. They're going to just keep following the track. If we look at the vertical profile, similar thing, right? In the vertical profile, we have a huge spread in trajectories, whereas with PBN, they stick way better to the prediction. In the end, increasing predictability, and if you increase predictability, you're going to increase capacity, you're going to maximize safety, and you're going to be more efficient, as you can see it here, right? In this case, where the definition of this yellow guy, this is an example, right? But in principle, if you have more capabilities to design procedures, you have the aircraft can fly more curves or more paths, the more efficient they are going to be, and in principle, you're going to save, you're going to fly less nautical miles and save some fuel. It's not a lot because you're descending, but in the end, it's more important to increase capacity to be predictable, because when an aircraft burns fuel while approaching is when it does a holding, because if it keeps flying in idle thrust all the way down, flying more nautical miles is not that important. But of course, it takes more time, and time is another factor to take into consideration in airline operations, right? Here you have an example with conventional arrival and continuous descent operations that, as you were seeing in the radar tracks, is helping PBN to implement. So thanks very much for your attention.